Welcome back, my dear students. I am Barkat Ali Meher, Assistant Professor of Physics from Government Degree College, Tull. As you know that we successfully completed the first chapter of the first year class of the physics. Today we are going to start the second most important chapter of this first year physics. And this is very important chapter for the physics learners because without understanding scalars and vectors we cannot understand the physics. As it is said that vector is a tool of a physicist. As you know that tool is very important thing for any professional person. As you know that stethoscope is the basic tool of the doctor, and the vernier caliper or scale is the basic tool of an engineer. Similarly, we can say the vector is the basic tool of a physicist. So it means vector is a very important concept. After completing this lecture, what will be your outcome? That you will be able to explain and define the scalars and vectors and their representation as well, and how can we add two vectors or more than two vectors graphically. Yes, after completing this lecture you will be able to define and add vectors. So let's come. As you know that the name of this chapter is scalars and vectors, so that will be in your mind that scalars and vectors we are talking about what. So let me explain. As you know that all physical quantities in the first chapter was divided into basic quantities as well as derived quantities. But in this chapter these quantities are again further divided into some other groups, and they are said to be scalars and vectors. On the basis of what? Let's see. So we are going to explain first the scalars and scalar quantities, and after that we will explain the vectors, or we can say vector quantities. So let's see what are scalars. Scalars, by name it is clear that having only a scale. Scale means having only a value, a numerical value, means only magnitude. No any particular direction is needed to explain this quantity that is known as the scalar. Simply I can say those physical quantities which are completely specified or explained by only magnitude and proper unit are known as scalars. Yes, my dear students, whenever you don't have need to explain the direction of anything, any quantity, that physical quantity is known as a scalar. Now let's see which are the examples of scalars. For example, if I want to measure the mass of this book, as you know that mass is only said to be the quantity of matter present in that body. The quantity of matter in that body is greater one as compared to this one. So its mass is said to be lesser than the mass of this book. But how can we measure the mass? Mass is measured with the help of physical balance. If I place this book on one side of the physical balance and put 1/2 kg or any other standard on other side, and the physical balance becomes balanced, it means the mass of this book is said to be 0.2 kg, 0.3 kg or something else. So it means for measuring the mass of this book, or the amount of sugar, or the amount of any iron or something else, we do not need to mention any particular direction for the measurement of the mass. Yes, we never ever say that the mass of north, mass along x-axis. Have you listened about this? Mass of sugar in a particular direction, then it will become sweeter than the other direction. Never ever. So mass is only scalar quantity. It is measured with only magnitude, only value. it does not possess any particular direction. It doesn't require any particular direction to define or explain the mass. So can I say mass is a scalar quantity? Yes, because suppose I measure the mass of the amount of sugar and that is 5 kg. So 5 is only the magnitude of that physical quantity and kilogram is its particular unit. So mass is said to be only scalar quantity. Which are other quantities considered as the scalar? Then simply I will say to you, all basic quantities are scalars. Isn't it interesting? All basic quantities, yes, 7 basic quantities, important one you have studied in the first chapter. These all are scalars. So mass is scalar, length is scalar, time is scalar, current is scalar, temperature is scalar, amount of luminous intensity is scalar, amount of substance is scalar. So all 7 basic quantities are scalar. तो ये भी याद रखन दो. इन खां अलावा अगर चऊं तो which are the other physical quantities considered as scalars? तो yes, you can say volume is scalar, density is scalar. अगर तव्हां ॿिया नाला वठण चाहियो था, energy is scalar, work is scalar, power is scalar, electric flux is scalar one, magnetic flux is scalar one, etc. केतरा भी नाला खणो, these quantities are considered as scalars. हाणे तव्हां चवंदो त how can we deal with the scalar quantities? How can we add, subtract, multiply and divide the scalars? Are we going to learn the new algebra for the scalar quantities here? Then I will say no, because scalars are added, subtracted, multiplied and divided by only common arithmetic rules. Simple algebra is required. That is already you knew from the basic classes. So simple algebra is required to add, to multiply, divide or subtract the scalar quantities. अगर मां तव्हांखे एग्जांपल ॾियां त सपोज हिकिड़े घर में 2 भाइर रहनि था. हिकु भाउ खंडु रांदी 2 kg, ॿिए भाउ खंडु रांदी 4 kg. How much amount of the sugar is present in that home? Yes, you will say sir 6 kg. अच्छा, गेस्ट आया ऐं उहे 2 kg खंडु खपाए करे हलिया विया त हाणे ॿुधायो त घणी खंडु उन्हनि जे घर में मौजूदु आहे. Now simply you will say 4 kg. सुबुह जो उहे पाण में विड़ी पिया, उहे 2 घर अलॻि थी विया. नाउ हाणे उन्हनि जे हर हिक जे घर में केतिरी खंडु मौजूदु हूंदी अगरि उहा डिवाइड कई वई इक्वली इन द बोथ ब्रदर्स. नाउ यू विल से सर 2 kg इन ईच होम. वरी ॿिए ॾींहुं उहे पाण में ठही विया. नाउ हर शइ कंबाइन थी वई. नाउ व्हाट अमाउंट ऑफ द शुगर प्रेजेंट इन दैट होम in which they are now living together? Now you will say sir 4 kg. So was there any difficulty to add, subtract, multiply or divide the sugar among the 2 brothers? Never ever. So it means scalars are treated as a very simple quantities, and you all know that how can we add, subtract, divide or we can multiply the scalars. So it means in this chapter the important one are the vector quantities, because vector quantities are those physical quantities which are completely specified or explained by not only the magnitude, yes, by the magnitude as well as direction and a proper unit. So these are the very different quantities. These quantities always require any mentioning any particular direction. Without mentioning the particular direction, we cannot understand about these quantities. Whenever we cannot understand about these quantities, how can we treat with these quantities? How can we deal with these physical quantities? So these are different quantities, and in this chapter we are going to learn the vector algebra, and vector algebra is required to deal with the vector quantities. For example, which are the vector quantities? If your teacher say to you, move 5 steps, is this statement is enough for you to understand in or you will say, sir, in which direction? Absolutely, you will say, sir, in which direction I should move? Upward, downward, backward, forward, rightward, leftward, in which direction? So it means you will ask from him, sir, in which direction. So it means the change in position is a vector quantity, and change in position in a particular direction will be known as the displacement. So displacement is a vector quantity because in the complete explanation, complete understanding for the displacement, you have to ask about the direction. Sir, in which direction should I move 5 steps? So displacement is vector quantity. Any person comes here and says to you that I have applied the 5 Newton force. Again you will say, again you will ask from him, in which direction you applied the force? Upward, downward, leftward, backward, in which direction? So it means force is which quantity? I can say force is a vector quantity because 5 Newton is not enough for the description of the force. 5 only is the magnitude of that force. Newton is the particular unit, but particular direction must be required to understand completely the force. So force is not a scalar quantity, force is a vector quantity. So force is always written like this, and all vector quantities are represented some arrows over them having symbol 5 Newton along positive x direction, positive negative x direction, positive y direction, negative y direction. These are all kinds of the some particular directions. So force is a vector quantity. I think it's very clear for you that force is a vector quantity because it has magnitude as well as direction and a proper unit. So those physical quantities which are completely specified by the magnitude as well as direction and proper unit are known as the vectors, or you can say vector quantities. Yes, these quantities are very different one, and to deal with these quantities we have to learn the vector algebra. So actually this chapter is vectors algebra, which is required to deal with these vector quantities. So the vector quantities scalars का different होंगी जी. मां simply इकड़ो तां मिसाल लिया त जीअं 2 plus 4 kg असां चयो से त that becomes 6 kg. So scalars के जोड़ करण simple आहे. अगर असां चऊं 3 plus 4 kg, then you will say 7 kg is the only answer in the terms of scalars. Yes, in scalars it's simple one, but in vectors 3 Newton force is there, 4 Newton force is there along the vertical direction. What will be the total force acting on a body? Suppose a body is being subjected to force of 3 Newton along x-axis and 4 Newton along y-axis, then how much amount of the force is acting on this body and in which direction? So 3 Newton is here, 4 Newton is here. So now the total force acting on this body will be 5 Newton. Yes, so 3 Newton and 4 Newton can be 5 Newton. We will understand in the vector algebra how it is 5 Newton, but we will study. Suppose 3 Newton and 4 Newton are parallel to each other. Now what will be the total amount of the force? Now you will say 7 Newton. If the 3 Newton and 4 Newton are opposite to each other, then what is the amount of the force? Then you will say only, sir, 1 Newton. So it's amazing that 3 and 4 can result 1, 3 and 4 can result us 5, 3 and 4 can result us 7. So this value is possible for the sum or addition of these vector quantities. So vector quantities are not simply added, subtracted like the scalars. So we have to learn the new ways to deal with these forces or vectors in which two values can have the maximum value as well as the minimum value, and the any intermediate value is also possible. So it means vectors are very different. So vectors में ये सभी जवाब थी सघन था, 3 4 जो जवाब हिकु भी थी सघे थो, 7 भी थी सघे थो, 5 भी थी सघे थो, पर ये simply 7 थे, that's not possible in the vectors. तो vectors हिकिड़ी अलग दुनिया है, तो vectors के असां clearly समझणो पवंदो. Now I will say conclude this definition of scalar and vectors. So which are the other examples of the vector quantities? Other examples जो अगर जिक्र अचे तो तव्हां चई सघो था, yes, force is vector quantity. Tell me. Displacement, yes, vector quantity. Velocity, acceleration, name it. Momentum, yes, momentum is vector quantity. Torque or movement of force is vector quantity. Angular momentum is a vector quantity, etc. Other forces, other quantities are there. So these are all vectors, and these were only the scalar quantities. I hope that now you become able to define the scalars and vectors. Yes, scalars are those quantities which have only magnitude and proper unit, and the vectors are those physical quantities which have magnitude as well as direction and proper unit. So it means all the physical quantities of the world are divided into two groups. One is the scalar, other are the vectors. Now we will further study about the vector quantities. Note it down. Yes, my dear students, after learning the definitions of the scalar quantities and vector quantities, now we are going to learn that how can we represent a vector quantity graphically. So our topic is graphical representation of a vector. हर वेक्टर क्वांटिटी के पढ़िया ऐसे द पर्टिकुलर डायरेक्शन मेंशन होंदी आ, तो हर हुआ क्वांटिटी जंहिंखे पर्टिकुलर डायरेक्शन हुजे उनखे अगर ग्राफिकली असां ड्रा करे सघूं, जीअं करण वञूं था त कीअं ड्रा कबो आहे, त ग्राफिकली ड्रा करण खां पोइ उन्हनि वेक्टर क्वांटिटीज़ खे डील करण आसान थी वेंदो आहे. जी हाँ, उन्हनि खे ऐड करण, सब्ट्रैक्ट करण या मल्टीप्लाई करण आसान थी वेंदो आहे. तंहिंजे करे वेक्टर क्वांटिटीज़ खे असां ग्राफिकली रिप्रेजेंट कंदा आहियूं. डिस्क्रिप्टिव फॉर्म में त ॻाल्हायल हूंदो आहे, पर उनखे ग्राफिकली भी रिप्रेजेंट कंदा आहियूं. त ग्राफिकली कीअं रिप्रेजेंट कंदा आहियूं, शॉर्टली तव्हां सम्झी वेंदो. तो सपोज था कहीं असां डिस्क्रिप्टिव फॉर्म में हिकिड़े वेक्टर जो बयान ॾिनल आहे त का शइ वेक्टर क्वांटिटी आहे. Suppose consider a change in position of an aeroplane which has traveled 400 km along northeast. So can we say this is the displacement of the aeroplane, because aeroplane has been displaced 400 kilometers along northeast. So you can say this is the description of a vector quantity, and that vector quantity we know that displacement, and displacement of that aeroplane is 4, and displacement is actually represented by S vector or R vector or D vector in the physics. So that's why I am using this symbol for the displacement. And its displacement is what? 400 kilometer. 400 is its magnitude, kilometer is its, yes, unit. And along northeast, yes, northeast represents the direction of this displacement. So you can say this one is a given vector according to this consideration. So according to this consideration, this is a given vector, but we are going to represent this vector graphically. Let's see how can we represent it. तो हाणे तव्हां ॾिसंदो त हिन वेक्टर क्वांटिटी में ॿ शयूं आहिनि, मैग्नीट्यूड बि आहे, डायरेक्शन बि आहे. त अहिड़े नमूने ग्राफिकली उनखे रिप्रेजेंट कयूं जो हिन में मैग्नीट्यूड जो बि ज़िक्र अची वञे ऐं उनजी पर्टिकुलर डायरेक्शन बि साॻी रहे जेका गिवन आहे. इहे ॿई शयूं ग्राफिकली कीअं आणे सघूं था, त ग्राफ पेपर ते तव्हां ॾिठो हूंदो हॉरिजॉन्टल लाइन्स बि हूंदियूं आहिनि, वर्टिकल लाइन्स बि हूंदियूं आहिनि. सो फर्स्ट ऑफ ऑल यू हैव टू सिलेक्ट द टू लाइन्स, वन इज द हॉरिजॉन्टल वन, अदर इज द वर्टिकल वन. This horizontal line is also known as x coordinate, or you can say x axis, and this vertical line is also known as the y coordinate or y axis. These are the terms for these lines in mathematics, you know. अच्छा जाते ये लाइंस क्रॉस कंदी दैट इज ओरिजिन हिन साइड के ता नेगेटिव एक्सिस चोंदा हिन साइड के ता नेगेटिव एक्स एक्सिस भी चई सको था सो ग्राफ पेपर दे ताके ब लाइंस पेरो सिलेक्ट करनी नी पर ता जो सर नो हेते दसा के नॉर्थ ईस्ट जो जिक्र है एक्स वाई जेड एक्सिस जो जिक्र त नहीं तो यस इट्स ओके तो तहां के हिते ब लाइंस ड्रा करन खपन जे के क्रॉस कन एरो शो कर नाउ इन मैप्स यू हैव सीन that this side is always represented as north side, north pole. This is east, west, and this one is the south side. So is this clear now? Y axis is now representing, we can say, north side. X axis now representing the east side. Yes, you can say. So it's clear now that this one is the north, this one is our east. But the problem is that how can we draw the 400 kilometer line? Is this possible to draw 400 kilometer line here on the board or on your paper of the copy? No sir, it is not possible. When it is not possible, now what you have to do? Then you have to suppose in scale. Supposition of scales are what? तो ता हिते 1 सेंटीमीटर रखो इन 1 सेंटीमीटर सपोज जेका लाइन आ इन जो असां वैल्यू खणंदा तो 1 सेंटीमीटर लाइन इज सपोज इक्वल टू 100 किलोमीटर अगर ता सपोज कयो तो 1 सेंटीमीटर लाइन इज इक्वल टू 200 किलोमीटर then you have to draw 2 centimeter line for the 400 kilometer as I have considered that 100 kilometer is equal to 1 centimeter. It means 400 kilometers will be represented by only 4 centimeters. Yes, it's very simple. So now it becomes possible to draw to represent the 400 kilometer with the help of only 4 centimeters. Yes, my dear sir. 4 centimeter ता line draw कंदो तो it means ता चई सको था that is 400 kilometer. So हाने हर शे आसान थी वई डायरेक्शंस जी भी असा खबर पइजी वई ग्राफ पे ऐं असा के मैग्नीट्यूड रिप्रेजेंट करण ला भी खबर पइजी वई तो for 400 kilometer we can draw only 4 centimeter line. That 4 centimeter line will represent the 400 kilometers. It's very simple now. So how can we represent this vector graphically? Now come to the final point. हाने ता चोंदो तो हे 400 किलोमीटर ला 4 सेंटीमीटर लाइन कढणी है पर 4 सेंटीमीटर लाइंस केड़े तरफ कढणी है तो ता चोंदो 4 सेंटीमीटर लाइन जहाज वयो नॉर्थ ईस्ट में. This is north, this is east. What is that angle between the north and east? You can say 90 angle. Perpendicular हुंदी उन्हीं lines तो ये 90 right angle हुंदी है. अच्छा north east में व्याऊं means at what angle? तो now you have to say 45. So the north and east भी का भी direction angle mention नहीं. तो ता पानी suppose कंदो तो north and east जो center means 45. तो ता एकड़ी शय करनी है तो हिते ता प्रोटेक्टर रखंदो प्रोटेक्टर रखबो है के डी हुंदी है उनते ता 45 एंगल के सिलेक्ट कंदो 45 एंगल वाले पॉइंट ते एकड़ो ता पॉइंट लगाइंदो ओ एकड़ो ता स्केल खणंदो उन स्केल जी मदद सा ता इने के ड्रा कंदो बट हाउ मच लाइन ड्रा कंदो ओनली 4 सेंटीमीटर. So now this vector हाने ता 45 एंगल ते एकड़ो लाइन कढी इन लाइन के ता एरो हेड दींदो हाने चई सको था this is a vector which represents the 400 kilometer along the north east direction. Now I am going to conclude that how can we a vector is graphically represented. You can say a vector is graphically represented by a line. Yes, there is line which shows its magnitude and an arrowhead which shows its direction. So every vector quantity is represented by such type of arrows. In every arrow there is an arrowhead as well as a line. That line represents the magnitude of vector quantity and an arrowhead indicates its particular direction. So this is the graphical representation of this vector. If it was said that 200 kilometer along east, So you have to draw only 2 centimeters along the east. If it was said that no, 300 kilometers along the north direction aeroplane has moved, then you have to draw only 3 centimeters line along the y-axis, or you can say along the north side. So in this way, go to home and you are at home, so that's why practice much more to draw these vectors. Jetri practice kando, that will be better for you. So I hope the practice ke taan continue rakhando. So he vector draw kare dekhayo in a vector ke chai sago tha that this is the vector of displacement which indicates 400 km along northeast. हाणे ता जो वेक्टर ग्राफिकली त हिय ठंदा with an arrow, पर ता चुंदो वेक्टर के symbolically किए रिप्रेजेंट करवा. This is the graphical representation. Now I am talking about the symbolically, in symbols how can we write the vectors. तो ताके हिय शे याद रखन खपे त हर वेक्टर जो को न को इनिशियल पॉइंट हुंदो आ. Initial point of any vector is known as its tail. Suppose O point is indicating its initial point, so O is now indicated as the tail. And suppose P is the terminal point of this vector, so P point, or you can say this is the head of the vector. So every vector has initial point, that is known as the tail, and the terminal point which is known as the head. So hinna vector jo nalo ta hiya bhi rakhi sago ta. So suppose this vector is OP vector. OP likhi kare arrow tandindo matha. You can say this is OP vector. But no, you want to represent it in a single letter, then you have to use the capital letter of English alphabet. So you can say this is A vector. Yes, OP vector or A vector. But you know that this is a proper vector. Jare bhi A, B, C, D, E, eda nala jaun, that these are not proper vectors. We are supposing some vectors. But as you know that this is displacement. Agar force ho jaya, agar velocity ho jaya, that they are said to be proper vectors. तो तांजनो हे को proper vector, तो हिन के हिनन नालन यानी की जरूरत नहीं, हिन के पंजी निशानी भी आहे. This proper vector displacement is represented by S vectors. So this is a way to write a vector symbolically. This was a way to vector graphically. Yes, now come to the point. अगर काथे हिये चलो जे the symbolically ता दिसी आयो तो vector OP vector, I can say A vector, S vector, or you can say bold letter of English alphabet. Yes, my dear students, अगर ता मथा arrow न दियो तो just bold letters सा लिखो A, B, C, but bold letter in computers you know that. So bold letters also represent vectors. But agar ता चलो this is a symbol of complete vector, but we want to mention only the magnitude of vector. Then magnitude of vector is represented like this. A vector जो magnitude A mod लिखनो. These lines dividing के modulus check हुआ, या we use the italic letters of English alphabet. Italic letters में लिखो, जी ऐसा जेके भी scalar quantities हुई उनके italic letters में लिखना हो M, F, जेका भी हुजे L हुजे T हुजे time हुजे italic letters में लिखाऊं. It means we are talking about their magnitude. So these are या ता bold A लिखेला, तो bold A के भी ता modulus में बंद करना, तो that will be magnitude. Suppose हाने हिये लिखो था, तो that is complete vector. अगर हिये काशे लिखो था, तो that is only its magnitude. It means now there is no any need to mention the direction. तो vector जे just magnitude जे बारे में गालायूं, तो ता हिये लिखना. माना कहीं particular direction जो जिक्र न था कहीं, उन्हें जे just magnitude जे बारे में फिलहाल गाला रहे हो, तो उन्हें जे लाए है symbols use कर दो. And these symbols are used for the complete vectors. So now I hope that you learned that how can we represent a vector graphically from that description, from that given statement. This is a graphical representation of vector, and this one is the symbolical representation of that vector. Note it down.